Okay, so hi, this is how to fill out the workbook for the experiment with ammonium iron sulfate and titrating it against the potassium permanganate. So when we were in the lab, we weighed out 9.8 grams of ammonium iron sulfate, made that up into a solution of 250 centimeters cubed. So we'll fill that in there. Volume of ammonium iron to sulfate was what we pipetted up. So that would be the 25 centimeters cubed as per usual. For the average titer, we might have gotten around 28, 29, around the 30 mark or just below it. We'll get our average of the two titers that are in 0.1 of each other. So we get this one, 29.1, and we'll take this one. Add them together, divide it by 2, and we should get the average of the two closest titers. So that's that section completed. If we scroll down here, the mass of the ammonium iron 2 sulfate again was 9.8 grams. That's what we weighed. The molecular mass of the ammonium iron 2 sulfate you can work out by finding the mass of two nitrogens, because there's a little 2 there. So 2 N's plus 8 H's plus an S plus 4 oxygens and so on. So you're going to find the molecular mass of all of these, which you can find on your periodic table. Add those all up and you should get a value of 392.13 grams. Now, so if I take what I weighed out and put it as a fraction over the molecular mass, I can work out how much moles per litre that would give me, the concentration. And I got that to be 0.025. Now, I didn't make it up into a litre, so we'll deal with that in a second. The volume of the volumetric flask that we did use was 250 centimeters cubed. So because that 9.8 didn't go into a full litre, it went into just 250, it's going to be 4 times stronger than if you actually put it into a litre, because a litre would be way more dilute. So you're going to take that 0.025 and multiply it by 4, because 250 is a quarter of a litre. So it's going to be 4 times stronger. When you multiply this by 4, you should get 0.099 moles per litre. And that's the concentration, the actual concentration of what's in your 250 centimeters cubed. Okay, so we move on to the next page. We're about here. Now, so we need to label our volume of the oxidizing agents and the reducing agents. So this is your average titer here. I got 29.15. The number that is linked with the equation, if we turn back, we have an imaginary 1 there in front of the KMnO4. So that's a 1. The volume of the reducing agent should be 25. The molarity of the reducing agent was what we worked out there on the last page, 0.099. Then looking at our equation again, we see that 5 is right beside the iron sulfate, which is our reducing agent. So we come to our usual formula, and we're going to take all of these and put them in. The only thing that's missing is the molarity of the oxidizing agent, which is the KMnO4. When we work that out, we will get this result as 0.01698, and what I've done is I've just rounded that to 0.017 moles per litre. Okay, so that's the job done. We've worked out the molarity of the KMnO4. Okay, so you can write that as an M, or you can write it as MOL per litre. Okay, sometimes it's very handy to do this in case we need to find out how many moles were in 250. And if we were to do that, how many were actually present in our 250, we'd have to divide this by 4. Okay, your observations, colour change was from colourless to pink. The average titer, which I got, of KMnO4 has fully oxidised 25 centimetres cubed of the ammonium iron 2 sulfate. From my calculations, I found the molarity of KMnO4 to be 0.017 m. Okay, and that's it, completely done.